In this tutorial, I'll be showing you how to build an advanced or intermediate airplane. First of all, I really apologize about my voice. I recently lost my voice. I had to yell a lot. And I also really apologize about the overall audio quality of this video, but I hope this guide will help you in building an advanced airplane. This airplane, I'm going to be showing you how to do systems for controlling the bank angle. So for doing a center bank angle hold or a center straight and level flight hold, I'll be doing that, as well as an altitude hold, as well as a speed hold, and I'll also be doing a compass heading hold on the rudder. I'm going to be covering all of those things in this video, as well as doing landing gear and showing you how to do some intermediate landing gear that can go up and down, so retractable landing gear, and also for a door that can open and close. So starting off with this fuselage, I have nothing in here. I'm just trying to start off with the basic fuselage and start from there. So first we can add in our pilot seat here, place down an engine. This beginning part will just be for just kind of getting the fuselage finished and the engine parameters, everything, the seat, all of that stuff. We're also going to be doing the landing gear and the door for this first part, and placing down our gyro and whatnot. So bear with me for this first part. It will be kind of self-explanatory. Maybe you've already done this before and you can skip to the more advanced stuff. I will be leaving comments, not comments, in the description. I'll have timestamps for each individual component. So for example, doing the altitude hold system, I will be leaving a timestamp for that. And same with the bank angle center hold. I'll be doing timestamps for those as well. And in this video, this guide will also cover tuning the PID and the test flights. So if you're struggling with that, this guide will encompass everything. It'll be all encompassing to really help out you no matter what stage you are at. I want to make sure everyone is able to complete this. Really quick, we're going to start with some of the simpler stuff and work our way to the more advanced stuff. I'm going to get a propeller in here and finish up the engine. So we'll go gearbox in case we need it. Aircraft propeller. We'll start. We'll keep this neutral. And we're going to finish up the engine. We will need, I will try to be doing this as quick as possible. So we'll get the engine done. And I'm also going to need a radiator. And we will also be using exhaust. Let me also get battery here. And then our fuel tank here, fluid tank large. So fluid port, for this tutorial I'm going to be using a medium engine. That's for our air. For our, I believe this one will be coolant, correct? What's going on? Let's take out that. That's exhaust. Here's our coolant. Why is it not displaying properly? Okay, I'm pretty sure that's coolant. Let me grab a pipe. Yeah, so here's for our exhaust. So we'll go ahead, we will grab a straight pipe as well as an angled pipe. We can get rid of the fluid port as well as the radiator since we have placed those already. Exhaust, I'm going to have dip out to the side here. This will be plenty far enough away. I don't envision the smoke getting in my eyes or anything. Smoke goes out there. I envision this getting in my way or being too low, so I'm just going to raise the prop a little bit. So we have our gearbox there, and then maybe this can come in a little bit so it's not too far out, and then place that there. Oh, well, I guess it wouldn't. No, let's see. Aircraft. Let's see if this sticks out. No, that'll be perfect right there. Okay, I like where that is positioned. That will be fine for me. Next, we need fuel. So I'm going to place my fuel tank conveniently in this cutout I made earlier. So we need to do two things with this. One, we want to be able to refuel the plane. And so I can't remember if symmetry is on or not. Nope, I turned it off. Good. And so wherever there's this hole, that's where we'll refuel here. And so I'm going to grab pipe. And to refuel, we use what's called a fluid hose anchor. We're going to set that down there. Bring our pipes from the other end. We are going to have the pipe. Since this is not a boat, we do not need to worry about this being a tight seal. Since this is just an aircraft, we can keep this design open for the most part. We'll have this split out here. And then where is this needs to come up? So let's bring this up a little bit. Please use the timestamps posted in the video description if you need to get to the area you need to get to. So for example, if you already know how to do an engine, perfectly fine. That is great. Just look in the description and skip all the way to the part where you know how to do an to where you want to do the part you don't know how to do. So if you know how to do an engine, skip this part and go to what you need to do. The reason I am including all of this is because I want to make sure I have one video that can help out everyone, no matter what stage in their building they are at. So if they are really knowledgeable about engines, that's great. If they're not, I want to be able to encompass everyone and have just one tutorial to do it all. So there's the fuel lined up. This engine is hooked up. Next, we will grab our control surfaces. So I'm going to grab a small one here and a medium one here. Medium. So for the ailerons, this is important. Oh shoot, hang on, I need to get rid of this. For the ailerons, on the left wing, or rather right, the wing I am currently placing a control surface for right now. You want the negative arrow to be on top. So this is how I normally do ailerons. I have negative arrow on top, and then on the other wing over here, we will do positive arrow on top there. Now, I'm going to do the elevator. For the elevator, since the way a plane is naturally oriented and the way this works, you will do the negative arrow facing on top. That is how the elevator is commonly oriented for an aircraft, for an airplane at least. Now for the rudder, you will have positive arrow facing to the right. Next, now what we are going to do is we are going to be putting in a door and our landing gear system. And we're going to have an openable door and retractable landing gear. So this is going to be semi-advanced. So for my door, I'm going to grab a robotic hinge. We will put the robotic hinge here. And maybe we'll say we want my door. Now, when you're building the door to your plane, you can see right now I am looking at the hinge. That means if my mouse is over the hinge, when I move this hinge, whatever I'm building on, it will move with it. Now, if I move my mouse down to where there's not the hinge, if I were to place this block down right now, because the hinge is grayed out, I'm actually not building on the hinge. So I want to make sure I'm building on the hinge because all of these we want to be opened up. And we'll say give it some decoration. We'll put that right there as well. And then maybe we can say we want this to be a window. So bring a window in here, make sure we're looking at it. Boom. And then we'll also grab 3x3 window. No, by now we'll want the 2x3 window. place that down on the hinge. And then we can also have, say we want our door a little bit bigger, we could place, just for the sake of decoration, we can place that. Now, I will be showing you a system, how to open and close this. Very easy. You are going to search toggle button, two-sided. So we want this. This is what we want. And we're going to have it, we don't need any more hinges. So I'm going to, oh, we don't have a lot of room to do this. We'll place the two-sided toggle button like that, so we are able to access it from both the outside of the plane and the inside. And then we are going to need something called a numerical switch box. We're going to need quite a few of these numerical switch boxes eventually, but I'm just going to be placing down one. And we're going to need something called a constant number. We're going to grab both of these. And once we will be testing these things periodically. Right now, oh no, this pipe kind of gets in the way. Let's see if we might have to move that later on. But for now, for our door, we're going to do our door mechanical system right there. Now, this is what you're going to do for the constant number. One of them needs to be a 0, and that'll be the default or closed position. So 0 is whatever position this first starts out of. So when you put the hinge down in the build menu, whatever orientation that is, that will be 0. And then for here, I'm going to go +1. And so for our off value here, second value off, this is going to be the default state of the hinge. So 0 will be in the off value, and then on, what's going to open it will be on the on value, and that'll be a value of 1. Now what we're going to do is the switched value, or the output of this, is going to go control the hinge. And then the power button is going to be your toggle button. And so now we are ready to test this once we put down a battery. For the sake of simplicity, I am going to be putting my battery right over here on the tail. It does not look very pretty, but that's all right. Another thing we will be doing, something intermediate that I like to do in all of my builds, is I like to place down a cable anchor for electricity. Now, this will be the permanent location for my cable anchor. Because batteries weigh so much, if I ever need to reconfigure the weight of my battery, I can delete it and I won't have to worry about rewiring too much stuff from electricity. So this is what it's going to look like for right now. Hook this up to electricity, the cable node, and now I'm going to bring that cable node to all of my electricals. Everything that needs electricity comes to the cable node. We got our toggle button, gearbox, gyro. Now, if the battery is too heavy back here and I need to remove it and reconfigure the weight to be in other directions, I don't have to worry about hooking up all of these electrical cable nodes. I just have to hook the battery up to here, and then this block here is very light. This will be permanent. Just make sure you place one in a good, proper location. Now, let's see here. This is hooked up to electricity, and this is all hooked up to data, and so we can actually test out our door immediately. Advanced Tutorial Plane. We're going to spawn this in and make sure this door is working how I want it to work. Nope, it's going in, and so that's fine. When that happens, when it's going the wrong way you want, you're going to go to your constant numbers, and instead of a value of it being +1, you're going to make it a value of -1. I'm glad that that happened, so I was able to actually properly show and explain more. Now, when we open the door, it opens. Not perfect, but for this tutorial, it does what we need to do. And I can hit the button from the inside and close it. So now we have a functioning opening and closing door. You will obviously be making yours a lot better and looking a lot nicer, but now you know the fundamentals to getting the actual system started. Now, let's move on to doing the landing gear. We are going to do the landing gear by grabbing pivots, and I like to use the robotic pivot, the compact robotic pivot. We are going to move this to here. And we should do, actually I think I might want to hinge for over here to keep it center. So for the rear wheel, I'm actually going to use a hinge. We'll take that there. And I'm just going to put a hinge. We'll use our hinge back here. And then I am going to start by taking 1, 2, making sure we're building on the hinge, 3. And I'm going to kind of have it maybe come out 1 and put our wheel here. Hopefully the wheel fits. It might not because of the way this thing, nope, that fits perfectly fine. So we'll put our wheel here. And next, what I'm going to do is we are going to have, might want to do another hinge. Let's see, center of mass. Oh, I did this kind of ugly. For now, what we'll do is I will have my wings stretch out a little bit more, turn on symmetry, stretch the wings out, and since the engine's up here, no, I need to figure out how I'm going to do this. We'll probably do our pivots. Perhaps we'll do our landing gear system out here, just for the sake of this video. It won't look good, but it'll show you the fundamentals to what needs to happen so you can start doing it in your own planes. So this is going to come down. We can put our pivot down here. And then we will start by building here. And then we will take wheel. We're going to use small wheels since we can turn the small wheels. Place them like so. This is not going to do what I want it to do, but let's put the pivot a little bit further up here. Let's make this a little bit further out, actually. Let's make it closer up here to the nose. And then we'll do the pivot out here. This will look a little bit smoother. 1, 2, 3. And then we'll go, oh, it needs to come out a little bit more. Oh, damn it. I hope there's enough room. If we need to, we can move these exhaust pipes, which we most likely will need to do. And so instead of that, we can do this. I sure as hell hope the smoke does not get in our face too badly here. Next, we are going to place our small wheel. I suppose we can place it under right there. Next, we are going to do the same thing that we did with the door. We're going to take, for our landing gear system, we'll just do it up here. We're going to take 2 constant numbers, place them down, and a numerical switch box. For 1, we want 0. That'll be the default position, being, this will be fine for now. Now I need to change this. I need to have this hinge. I need to have them both start at the same position. So this needs to come down. My apologies. I don't like wasting time, but this change needed to happen. I apologize about that. We'll take this hinge and we will do a system where it's going to need to come out like this. And that way, this will not interfere with it as much. That should work. That should function a little bit better, although this is a little bit off, and so I think we just need to make it, let me go back. Yeah, this needs to be one up, one higher. So put the wheel here, and we can do that in a moment. Now we are going to reconfigure this. So 0, one of them is going to be a value of 0. That'll be the off value. The other is going to be positive 1. We're going to hook up 0 will be hooked up to our off value. Positive 1 will be hooked up to our on value. We're going to take the switched value and we're going to put it in both the rotation target and, no, wait, the rotation, yes, the output of the numerical switch box goes into all of your landing gear pistons slash pivots slash hinges. And then we're going to grab one toggle button, and then we're going to label this the landing gear button, and we will put this, since we don't need it directly for flying, we'll put it off to the side down here. Oh, dang it, I need to turn off symmetry. Label this toggle gear, and this gets hooked up to that electricity here. And now we are ready to test our landing gear system. We can open our door, we'll test our landing gear, and it looks like nothing happens. And the reason nothing happens is because I'm an idiot and I forgot to hook up electricity to our landing gear system. So here's the pivots for the landing gear, and here's the hinge for the landing gear. We forgot to do that. We will save that now and spawn it in. Every time you build, you test. Landing gear, we're going to hit that. It looks like we got lucky and our landing gear worked perfectly. That's exactly what I wanted both of my landing gear to do. If you wanted your landing gear, actually, you know what? I might put some PIDs and some mechanical stuff right there in that space, and so I might actually want my hinge to go the other way towards the tail, and so actually we'll have this hinge go the reverse way, and that could easily happen for you as well, and so that's good. So what I'm going to do is I'm going to grab what's referred to as a numerical inverter, and this is something you might have to do if one of your landing gear systems doesn't go the way you want it to go. You'll need to grab what's called a numerical inverter. You're going to go directly to the numerical switch box that controls the landing gear. You're going to go to that output, and you're going to deselect the hinge, and you're going to put it into the numerical inverter, and you're going to put it back into the hinge on the specific landing gear mechanic system that you want inverted or reversed. You're going to put it in there. You're going to hit save, and then now we can test it out. So ideally, what will happen when I hit the button is, my apologies, we're back. Ideally, what will happen is this is going to go up that direction. Let's test that to make sure it works. So as you can see, the landing gear now does what I want it to do, which is to go back that way, which now leaves us space to put mechanical stuff in that area there. This will be perfect. So now we're going to come back. Moving on to the next section, we're going to hook up the engine and make sure the engine and the speed is working properly. This portion is also going to include a speed hold system. So for our aircraft controls, or for our throttle or our aircraft speed and whatnot, we're going to set blade pitch to neutral, and we're going to grab a throttle lever. We're actually going to only need one of these. Bear with me. This is one way you can do things. And I'm going to put this again kind of off to the side, not too important. We'll put that there. And this is going to control, this throttle lever is actually going to control the collective. Now, this is also going to control our reverse. So what you do, if you want reverse, come to your throttle here. Minimum value, you're going to change it to -1. You can change the sensitivity, it doesn't matter what it is. This part doesn't matter what that is. -1 for the minimum, maximum for the +1. This is going to allow us to do reverse for our propeller. Nice and simple. I believe we are going to want 3:1. We'll start with 3:1 for the off value, and we can adjust that later on as we want. Let's make sure everything gets hooked up to electricity, throttle here, that's hooked up. And then for now, we'll say, we don't need to hook up the gearbox right now. I don't know if we'll need it. But now we're going to be doing our engine throttle. And so for me, I like to be doing engine throttle through the up and down arrows. Now, instead of putting it directly into here, we actually need what's referred to as an add block, because we are going to, again, this is the system that allows us to do a speed hold system that'll also control the throttle. Now, the thing is, you also want to be able to control the throttle manually. And so we're going to be, this will allow for us to do both options. So we're going to put our add block here. This will be for the engine. And so where's my, so I'm going to click up and down arrow, and we're going to put that here. The other thing we're going to need is a PID. So this is going to be the speed hold. Put a PID down. Now the PID output is also going to go into the add block from our, so we have our up and down keys. This will allow us to control the throttle manually. And then we have our PID output. This is what will control, this is what will hold the speed automatically for us when we want to do it. These go into the same add block. And the output is going to be going into the throttle. Now, really quick, we are going to place down our speed sensor, and I'm also going to, we'll just do this one step at a time for now. And so we're just going to go, we'll put our speed sensor up here. So here's our speed sensor. Additionally, for the speed sensor, what we're going to want is we're going to want a dial. And so again, I'm just going to be doing everything one step at a time. So we have the speed sensor, and now we're going to hook up the dial that'll have our speed. And so here we will write speed. So speed is going to get hooked up. Now this linear speed sensor is going to be hooked up to two places. We're going to put it into our dial for our speed reading, and then the PID you placed for your speed hold, you're going to put that down to your process variable. The next thing we are going to need is we are going to want a keypad. So now we go to keypad, put that down. Here is going to be our, I really hope it lets me put the damn thing down. It does not. That is not good. We are not going to have a lot of space. We'll put the keypad down there for now. So that's all right. We can call this speed hold input. And then this is also going to need a toggle button to turn on and off. Hopefully it lets me put the toggle button here. Of course it does not. I preferably want it in this area. Nope. Nope. So instead we're going to have to put it, we can probably put it over here. So we'll put our speed hold system here. So we will call this toggle speed hold. Now this is going to be used to control our on and off for our speed hold. So this will come to the PID activation. And now for the set point, we are going to use the keypad. So the keypad we placed is going to be the set point for the PID. So here's the PID set point. So here we go. This is hooked up to that. That's hooked up. Okay, so now let's make sure this gets, oh, and let's tune it really quick. So the PID for proportional, we'll probably start with something as 0.1. These are just starting values. We will adjust this in a moment, but we're going to test this out. derivative we will put as, well, we can keep this as 1, I guess, for now. We'll see. And then we'll put this as a 1 for max value. We're going to save this. And now we're going to go and test. We're actually going to test the speed system we just created. And before we do that, I'm going to need, oh, well, this all needs to get hooked up to electricity. So now we created the speed hold. Oh, shit. Yep, put that there. So we are going to go test our speed hold system as well as our general engine performance. So, oh, another thing, before I forget, our aircraft, the propeller pitch, did we already hook that up? We already hooked that up to neutral. Okay, so it is titled, this will be prop pitch. This is what's going to help us control if we want to go reverse or forwards more. But that'll be, for the most part, this will be static. We'll have it set to something. Next, we are going to come in. So I believe this engine, we are actually ready to test this engine. So good, it starts. And so I'm going to input speed. We'll call it 70. Hopefully we get a speed of 70. I'm going to increase the pitch, and we're going to activate our speed hold system. Our speed hold system does not work. Oh, and the other thing we forgot to hook up was I just needed to get the elevator hooked up really quick. Let's just do that really quick. WS. Don't do this. This is not going to be permanent. I'm just doing this really quick to test the engine speed. But this throttle, one of these toggle buttons needs electricity. Yep. Whoops. My apologies here. Save it. And we just need to get off the air. So we will, our propeller pitch will be positive. If we wanted to go reverse, we would go into the negative. And you can actually see, if we move this, you can actually see the propeller pitch being moved. So that's in the negative position. Here's closer to a neutral position. And then here's more of like a positive position. So you can see the blade moving. So we're going to keep it all the way positive. Speed, I'm going to input 70, toggle that on. And so as soon as I turn this on, the PID ideally is going to control us. So here we go. You can see our speed is climbing. It's trying to hold its speed at or around 70. It's not too far off. I'm going to turn off our speed hold system, and I'm going to hold down up on my keypad to see what kind of speeds we're getting. Okay, wow, we're getting a speed of 107, 108, so this plane is definitely capable. So we might need to tune this PID. We are going to do that now. We're going to do the speed hold system in its entirety. So I hooked it up just now, and now we're going to tune the PID for it. So what was happening earlier is it just wasn't quite reaching there. And so where is our speed hold PID? I think it's this one. Yeah, this is the first PID. So our proportional, we might need to make that a little bit stronger. We'll put that at a 3. For the integral, we'll say a bunch of these zeros and a 1. And then derivative, it didn't seem like we needed to change much, and so we will keep this. So now we are going to hit that. And we're going to see if this is better or worse. Before it was giving us a speed of 66, so not the end of the world. As long as you really, you can just be within like 4 to your standard. We'll keep blade pitch at 100. Okay, so we want it to go at around 70. So now as you can see, we are getting closer to 70. It's changing a lot because we're also changing altitude. But this is closer to what I want, and so this, in my book, this standard, or this is good enough for my standard. This is now complete. We have our altitude, or no, we have our speed hold system working. If I want to, I can take it off, and I can use the up and down keys to control my throttle. So you now have a system where you can control manually, and you have an automatic system. we are going to now move on to the next stage in building. For the next part of this tutorial, we are going to be doing the altitude hold system. Now for the altitude hold system, I am going to be using a numerical switch box system as well as a PID. So we will put both of those items down now. I have my PID on the left and I have my numerical switch box here on the right. Now, to hook things up, what we are going to do is we are going to grab our W and S from the pilot seat. So grab W and S from the pilot seat. You're going to come to the numerical switch box and you're going to go into the off value. So by default, we will be using the pilot W and S controls to control our pitch. Now, for when we turn on our on system, it's going to be controlled by the PID, and that'll be controlling the pitch of the plane to get our desired altitude. So you can take PID output, control output, and that's going to go to the on value. Now, this switch box, the output of the switch box is, again, we are controlling the pitch. So we're going to come down here to pitch onto our gyro that we placed earlier. And now we're going to take the output of the pitch from the gyro and we're going to put that into our elevators of the aircraft. Now we need an altimeter, another keypad, and I think one other thing, dial perhaps. So we will just get everything we need. So we're going to go keypad and we'll replace the constant number and we're going to go altimeter. Here is our altimeter. We are going to place that. We'll get rid of the linear speed sensor. We are done with that. I'm going to place my altimeter over here. Let's just make sure. Yep, altimeter, altimeter. Okay, good. So the altimeter is going to come to actually two places. So we're also going to place our dial now. So we'll place dial now, and this will display our altitude. And then we're going to place our keypad down here. And this, we're going to call it input alt hold. And then we are also going to need another toggle button. And for the toggle button, we can put it, I'll put my toggle button here, kind of follow this pattern. And this is going to be toggle alt hold. Let's get both of these, let's get all of that hooked up to electricity, and then we will go with the data configuration, hook this up to electricity. So now, we'll also stay organized by saying altitude. Yep, so we already labeled it. So we're going to stay organized by, so now to turn on the system, the toggle button that turns on the system, you're going to hook it into both the PID and the numerical switch box for your altitude hold system. So now it's one button press will activate the entire thing together. Now let's finish getting the PID set up. For the set point, again, you're going to hook it up to your keypad. Input altitude hold, that's what we put up earlier. We're going to input a number to display our desired altitude, and that's what the PID will try to achieve. Now for the process variable, we hook this into the altimeter we placed a few moments ago. This altimeter is going to be what the PID tries to correct to, or what it tries to work towards, rather. So these are hooked up. So if everything's hooked up here, let's see, make sure electricity. All right, now let's get started on tuning this PID. This is really important because of the natural way an aircraft, or rather an airplane, is oriented, especially the elevator, with these negative arrows on top, the PID is going to function like so. We need to put a minus sign here for your proportional. So you're going to do negative point, and we'll say we're going to start with 0, 1. So negative 0.01 integral, we're just going to keep 0. And for derivative, we will say minus 1. 0.5, just in case we want it to be a little bit smoother. For the max value, this is important. Do not ever do something like this. You do not need to do negative 1.5 because we're working in negatives. If you were to have the max value as negative 1.5, it actually means nothing would be happening since we're talking about a maximum value. You actually would just keep the maximum value at 0. And what you have here, this is something that would be more appropriate. This is something that could function. So keep max value at 0 when these terms are negative. We are going to save this and we are going to test our altitude hold system now. So we set up the altitude hold system, and now this tutorial is also going to include tuning it. A lot of the other guides do not include this tuning. We're just going to hold our speed input. So it looks like our pitch, when the system is off, it looks like we can control our pitch normally. Now, let's see what our altitude hold system does. I'm going to input a value of 600, and we forgot to hook up the altimeter to this dial, it seems. But let's see what happens if we hit this. Okay, we need to hook up our altimeter. And also, it looked like that plane was skyrocketing, and so we'll have to do a quick adjustment there as well. So it's good. So this is why we always test. This is probably something more realistic in terms of this guide. Aha, so look, the altimeter, we hooked it up to the PID process variable, but we forgot to hook it up to our dial. So that's going to be very important. We're going to actually want to be reading our current altitude. And then for the PID, I noticed the plane was skyrocketing a little bit. So we're going to say add another 0 here, but I'm worried that it would be too weak if we did that. And so I'm going to make that say a 2 or maybe a 3, and then we'll see what this system does. So advanced tutorial or advanced plane. Yeah, so this is what we're working with. We'll spawn this in. And remember, here's our propeller pitch. We'll keep that positive speed input. I'm just going to go to 80, nice and simple. Once we turn the key on, we're going to accelerate very quickly. This plane is quite nice. Now I'm gonna input, here's our altitude, so we'll go 500, not 5,000, just 500. That's our current altitude, 200. I'm going to activate the system, and let's see what the plane does. So far, not bad. Not bad at all. We're going to keep waiting. Let's wait for it to get to 500 and see. Now you'll notice as we get closer and closer to 500, it starts to slow down a little bit more and a little bit more. And we have overshot, and so now we're at 503, 505. We are continuing to accelerate, and so it looks like we might need to have a stronger D term or a D value. Note, I have not even hooked up roll at all to this plane, and so we're just going to be stuck here like this, 511. You can see it's starting to decline. So this needs more tuning. I am not satisfied with this. This is starting to slow down. It's starting to hang out at around 512. I am not happy with this. And so we are going to come back to the base, and we're going to continue tuning the PID for our altitude hold system until we are satisfied with it. Now, to start, I am going to start by saying this. I believe we could make it a little bit stronger in terms of what it's working towards. And so I'm going to take that from a 3 and I'm going to turn it into a 6. I'm going to double that. And then for the D value, the derivative here, that stands for dampening. I'm going to make this value a little bit bigger. I'm going to make it a value of 2.5. And that means when we get closer and closer to our desired altitude, it's going to deaccelerate more and more to try and prevent overshooting. I am happy, I think, with those current terms. So I'm going to save it and test our altitude hold system again. Start, and then for speed, we can put in 90 for now. I'm going to activate the speed hold. You can hear immediately the engine throttle works really hard. We're going to put in an altitude of 500. Speed is holding at 90. I'm very happy with our speed hold system. We're going to activate our altitude hold. So we were at 250 earlier. Now you can see we're trying to go to 500. Here's the altimeter. displaying our altitude. We want to be at 500, and this is it working. As you can see, we're starting to slow down as we get nearer and nearer to 500. Here we go. We have overshot. Before we were going to 512. Now we're at 503, 504, 505. This is better. This is definitely better. We're still rising. It's still going. But it looks like it's staying stagnant at 505.6. It just went down a little bit. Oh no, 5.570. Another thing, I don't have any roll. So this might be contributing to the fact that the plane is at a slight bank angle currently. And so that could be contributing. So we're at 505.6. So that looks pretty stagnant. This is a little bit better than it was previously. What I'm going to do is I'm going to hit this to 200 and see what happens. So before it was going 5 above our desired altitude. So we'll keep that in mind. It was going 5 units above our desired altitude. And so we can make slight adjustments to our keypad. There's fancy stuff we can do with the keypad that I will show later. Or maybe soon, depending on what this is. But now let's go to 200 and let's see what it does at 200. So it was doing 5 more earlier. So let's see. Let's see what happens here. We want it to go to 200. And let's see where it stays at. Yeah, it looks like 205. Looks like it's going to stay about 5 values higher than normal. It's starting to slow down. Now what we can do is we can try changing the integral value, which we will do now. Yeah, it's hanging out about 5, so we'll do a couple of things. We'll do... So something you could do to mitigate that. By the way, within 5 values is still quite good. If you want, you could totally have that be acceptable, and you just know when you use your altitude hold, it only goes within about 5. But right now, for the fixes, let's say you did want to do something more accurate, you would grab what's called a function block. We'll put that here. And the other thing we'll do is we'll come to our PID. For integral, we're going to go negative, and we'll go 0.00. We'll probably do for these 0.001. So add in an integral. We can do that. File. We'll save it. And then the other thing we can do is we can put in a function block. And we'll put in the function block over here to keep things nice and simple since we're still working on altitude hold. So for the function block, remember, we were getting 5 values greater than what we wanted. So we're going to hit x minus 5. If you were getting 5 values lower than what you would wanted and you want to add more, you would add plus 5 or plus however many or whatever the difference is, that's the number you put. For me, if we're going 5 values too high, I want to put x minus 5. You just take the difference. So that gets hooked into there. Now we're going to go to our set point. So our little keypad over here. Here's where we put in the number for our input. We're going to put it into the function where it subtracts that value, the difference, and that's going to be our new PID set point. Here's the PID set point. So there we go. So now we take in our keypad. So whatever you put in the keypad, it's going to magically just automatically subtract 5 and put it into there as the set point. So that works like that. We can spawn this, so we're going to test our altitude hold system again. Prop pitch. Speed, let's just change the speed just for the sake of it. Turn it on. See if we can get to 100, and then for altitude, we'll input 500 again. We'll activate it. We're at 300 right now. PID likes to control it nice and slow. So here we go, 460, 490. So something really bad happened. It's just not caring at all. We've really fucked this up, it looks like. So we'll have to come back. So we'll come back to here. I'm not sure exactly what happened. We can look at our, we can look at some of the logic we did here. We might have messed this up. This is coming in from the input for the altitude hold number, and then it goes to the set point. That's what we want. Let's make sure it's just x minus 5. Shouldn't be anything that detrimental. So then it's most likely it's this integral value. We'll get rid of that. And you know what? We'll say we're going to make this a greater value. We're going to make the D term, the dampening, a little bit better. Hopefully that prevents the overshoot a little bit more. We'll spawn this. I don't know if I can't remember if I saved it or not. I apologize, but we'll save that. We'll save those changes I just made, and then we'll fly it. Really quick as a bunny. 90. Turn on that system, prop pitch. Start accelerating. We'll put in 500, and then we're going to activate our. It's very interesting. We nosedived. I think we put in our. It's possible that as soon as I entered the altitude hold, or as soon as I activated the altitude hold system rather, the plane dipped down a little bit while we were trying to take off, and I think that contributed to the crash. We won't do that again. 500, so we'll take off. We're clear of the mountain. We'll activate our altitude hold. Nope, something very wrong has occurred. Our plane is no longer functioning. I don't know why this is happening. Let me make sure this is just a regular function input. In case I mess something up here, we're going to get rid of that function block. I don't know why that it's not working currently. I've done this before and something like that has worked, but just in case that's the problem, we'll put this to the set point. Let me make sure the PID values here are negative. Oh, this is interesting. I don't know why this is a 1, but that should be a 0. I don't recall doing that. That's frustrating. So now I actually want to go back where our function block is. Keep the function. That was set a 1 earlier. What's going? I don't save it. So now let's load it. I think the game is just being buggy right now. So integral is at 0. We'll keep the -5. Let's test this one more time. I'm starting to get a little bit annoyed here. Speed, we go to 90. Activate. We're going to pull up. So my flight controls manually work perfectly fine. Let's go ahead into our altitude hold system. 500, we'll activate that. And we'll see what the PID does. So it looks like now it's starting to work a little bit better. So we did raise the D value a little bit, so the dampening value should be a little bit stronger. So as we get closer to our desired altitude, in this case 500, it should start to slow us down a little bit more, and hopefully that prevents an overshoot. And we'll see. We're going to just sit here and watch it. 490, 493, 495. So it looks like we're going nice and slow. Very gentle here. It's starting to slow down a lot. This is good. So the stronger D value is working hard to slow us down as we're getting closer and closer. This should help us prevent that overshoot. And I believe the function block is still there. So yeah, so now the function block where it subtracts 5 is also going to be working hard. So as you can see, we've just hit 500 and it's staying nice and stable. We're not at 501 yet. We're not at 502. We're not at 503. We're just at 500. Well, 500.80, but within 1. If you can get your system within about 2, that's a good system. Let's see what it does. It's just hovering at 0.90. It's gone down a little bit. It's coming, I saw it go to 0.80. Nope, now we're at 501. It's probably going to tinker in and about here. Let's see what it holds at. If you want, toggle our toggle gear, or our landing gear rather. 501.4, 501.6. It's not going to be entirely perfect. It's not going to be 100% perfect. Looks like we're going to be within about 2. This to me is about satisfactory though. It should hang out about here. 501. It was at 501.90, now it's at 502. It is trickling around here. It doesn't seem to be climbing that much higher. There we go, 501.9. Yeah, so it's not, there we go, I just saw 501.8. It's because of our bank angle. Our bank angle we don't even have set up yet, and so this is perfectly normal. This is going to be perfectly normal. We'll test it one more time. We're going to bring our altitude down to 200 and see what this does. Plane appears to be within control for the most part the entire time. It's not working too fast, it's not working too slow. It's pretty stable. So we're going to 200 and we're at 250. As you can see, nice and stable. It's not trying to do anything too drastic. 200, 15, 213, 212, 210. So ideally this will be within about 3 or 4 values of 200 when it starts to settle. I predict it'll be around 202, maybe 203, since when we went to 500 it was at 502. Still climbing down. Now at different altitudes sometimes it does different stuff. Yeah, it's coming down a little bit. Yeah, you know, I'm just gonna say for the sake of this tutorial and for the sake of speed and progress, this seems to be an appropriate system. This is working within my comfort standard. I like this system. This system is satisfactory enough for me, and I'm going to say that our altitude hold system is complete. When we want to, we can toggle it off, and I can adjust the pitch manually like so. I do apologize because originally the audio from my mic was not working when I first did this for the tilt sensor to do the auto bank angle hold or the center hold system. And so we're going to do that right now as quick as possible. So you're going to need a tilt sensor and you only need one tilt sensor. And what you're going to do is, depending on the orientation of your ailerons, you're either going to have it face directly to the left or directly to the right. And that's what you're going to be doing. For my aileron orientation, commonly what just needs to happen is it faces to the left. You might need to have your tilt sensor facing to the right depending on your build, but for me and for all of my planes, it's usually facing to the left. And so now we're going to put this in. We need a couple of other things. So I just placed the tilt sensor down. So we're going to be getting our roll completely set up on the gyro and adding in the bank angle center hold system. So to do this, we are going to place down a PID. So we placed our tilt sensor down earlier. So we'll place the PID and we're going to place an add block together. I need one other thing. This will come later. I'll explain that in a second. So for now, to get our roll, what you are going to do is come to your seat and you are going to take A and D for roll, and you are going to be putting this into your add block. You're going to add this to B, and it doesn't matter if you add it to B or A. And now go to your PID controller, the PID you want to use for your bank angle center hold. Now put that into the add block as well, so you have both of those going to the add block, and then the add block output you're going to put into the gyro roll. Where is gyro roll? Here's gyro roll. And then now what we can do is we can continue this system, or continue the line rather, take the output gyro roll, and then bring this over to our ailerons. And now what we will do is we will go place a toggle button. We will have a button for the system. So I will place my toggle button here, title it bank angle center hold, and we are going to give this electricity. I have other systems in here that you have not seen in this tutorial because I had to reshoot this portion of the video. So your toggle button is going to turn on the PID, and because we're using an add block, you don't need to turn it on or off. Now we're going to hook up the PID. For the PID, we are going to get the our process variable that we're working with is going to be that tilt sensor we placed earlier. So here's the tilt sensor we placed earlier moments ago that's facing to the left. And then this is really important. For the PID set point, you are going to grab again what is called a constant number in the inventory. It's called a constant number. Click it, make sure it says 0, and you are going to be hooking this into the PID set point. That is going to be the PID set point. And if all of these are added up, hopefully and preferably hooked into the gyro roll. Yep, we are now ready to test the system. So let's go ahead. Oh, we'll save it, but really quick, we're going to also want to tune the PID very quickly. So here's the PID we were working with. I'm going to put integral for 0, max value for 1, and I'm just going to keep these values of +1 and see what happens when we fly this. So we'll get out in the air. Open our door. We can just put in 80, turn everything on. So now what we can do is now we will go ahead and test our ailerons work normally. We can control roll. Now I'm going to activate the system. And as you can see, the system starts to bank slightly centered. Let's make sure, let's grab a, we're not going to grab anything. Let's make sure we put our altitude at something stable, and this will make sure to help us visualize that our bank angle is working properly. So we're going to hold at 500. Turn that off, go a little bit lower, and right there. Hold there. Okay. Let the PID do its thing. Center. Alright, so our altitude's fine. So now I'm going to bank far left, and I'm going to let go. So manually, because we have it hooked up to an add block, we can use both. So if you look at the gyro, you can see it's snapping back into place. Now let's just wait and make sure it does not overshoot. It looks like it is not overshooting. I'm going to dip the nose down. Oh, I can't. Let me take off altitude hold. I'm going to dip the nose down a little bit. We'll try coming to the right just a little bit. And we're going to just stare at this gyro. Yep, looks like it's starting to center up. Nose down a little bit. I actually want this to work a little bit firmer, so we're going to go back to the workbench, and we're going to make some of the values a little bit different. We're going to make these values a little bit stronger. So I'm going to say I want it to be twice as rigid as that. So I'm going to change the 1 to a 2. And we're going to save this and fly it. So I'm going to test our bank angle center hold. So I'm going to turn it on. I can take the gear up. All right, it seems to be working. I'm going to roll to the right. Oh, let's avoid hitting that so we can fly low to the water. You can see the wheels turning. The wheels will be hooked up. The wheels are hooked up currently, but I'll have to hook up the wheels properly for what you're watching. The wheels will be hooked up later on. Remember, I had to come back to do the tilt sensor because my audio wasn't working. We'll bank to the left and we'll watch this. We'll watch this gyro. And we'll make sure it doesn't overshoot. So it looks like the plane is staying perfectly level. So again, we'll just test it one more time. Come to the right and see what happens. We'll make sure this gets... We're only worried about the roll or the bank angle being level. Okay, yeah, it looks like this is working. I want it to be a little bit firmer though still. And so we'll take the 2 and make that a 3. Because of this design, using the ad block for roll, you are able to, even when your center hold system is on, you can still make fine-tune adjustments to the aircraft's roll. So we'll test it now. I believe I made that a 3. This appears to be working nice, and this appears to be working better, so I hit bank angle to the left and it's center. So I'm actually satisfied with the extent of this, and so the next portion I believe will be the compass heading hold. In this next part of the tutorial, I am going to be putting in a compass heading hold system into the aircraft, and this will be hooked up directly to the rudder or the yaw of the airplane. And so let's go ahead and get this system operational. So we are going to be using an ad block for both the pilot controls and our compass heading hold PID, or our heading hold system. And so to start, we're going to go on the other side of the vertical stabilizer. We'll place an ad block and we will place the PID. So let's get the rudimentary components hooked up. So first thing is first, to control the yaw of the plane, I like to use the left and right arrow key, and so do most people. So I'm going to take left and right, and I'm going to be hooking that into the ad block. It doesn't matter whether it's B or A. And then for the PID output, I'm going to be hooking this up into the other portion of the ad block. We want to be careful that I don't hit any of the other stuff back here. So we have the PID output going to this ad block, and then the ad block output is going to be coming into the yaw of the gyro. So we're going to look for yaw. Here is our yaw. And then quick note while we are here, because this is an airplane, we do not use the up down on the gyro. The gyro's up down on an airplane for the most part goes completely unused. Many airplane builds I have seen from the workshop completely ignore the up down. All of my planes ignore the up down. You do not need it. So yaw is coming in from the ad block that we just set up. We put stabilized yaw into the rotation of our rudder. Now what we are going to do is we are going to place down some things. So we need a compass sensor. So here's our compass sensor. I'll put that there. And then we're going to also need a function. I already have a function logic here in my toolkit. And we need our keypad, which I have, and another toggle button. So let's go ahead and put this stuff down. So the next thing we're going to do is place our compass sensor. Make sure your compass sensor is facing completely forwards. So we're going to place that down. And I believe the compass sensor needs electricity. Yes, it does. Compass sensor gets hooked to electricity. Now, unfortunately, you would think by this point now that we would put the compass reading directly into our PID's process variable if we want to do a compass heading hold system. Unfortunately, the game is not this simple, and the compass sensor only displays a value between -1 and +1. You'll notice for a compass, for it to function properly, you need a value anywhere between 0 and 360, and these will represent your compass heading degrees. For example, 90 degrees is east, 180 degrees is south, and so on. Unfortunately, I wish the game could have been just better and the compass sensor just would be normal and displays a value between 0 and 360, but unfortunately, we are going to have to do a mathematical equation to do what the compass sensor should do in order to function normally. It's very unfortunate, and I wish this wasn't the case, but please bear with me and follow what I do. You're going to take your compass sensor reading, and you're going to click and drag this over into the function output, or the input here. You're going to click and drag that into the function, and you're going to click on this function block, and you're going to type in exactly what I type in here. And I'm going to be reading off of what I have written down, and this works in all of my other systems. You're going to do 2 parenthesis marks or 2 parenthesis inputs, a minus sign, 1, and you're going to hit Shift 8, or rather a star for the multiplication. The game uses this for multiplication. It uses that star. So you're going to do parenthesis, parenthesis, -1 times x, which is going to be our variable. You're going to do another times, so Shift 8, or the star icon, 360 here, and you are going to then add 360, bear with me, parenthesis mark like that, so close that one, and then you're going to do a % sign, and then 360 again, and now you're going to close the parenthesis. This is the entire mathematical equation that will successfully convert any value between -1 and +1 to get a value between 0 and +360, and this will represent your compass bearing, and this is what your compass needs in order to function properly. I wish that the game's compass sensor could just do this for us automatically, but instead we have to input it here, unfortunately. But just do that, whatever's typed in there, that's what you need to put into your function block. We're going to go to data here, and now for the function output. Now this will be hooked up directly to our PID process variable. So that's going to be the PID process variable. While we're here, I'm also going to grab another dial, and we can get rid of the compass sensor since we only needed one. And then now we're going to go ahead and put this system into our aircraft. We will put it over here. We'll say we need our toggle button as well. And I guess we can do it down here. So this is going to be, we'll title this our compass bearing. So this is going to display a value between 0 and 360. And this is going to be toggle compass heading hold mode. We're going to hook these up to electricity. And now what we're going to do is, for one, what we plugged into our PID process variable from so directly from the function block that's inputting our compass heading, we are also going to put that over to our dial. And so that way, where the heck is my dial? We're going to put this into our compass bearing dial so we can see what our compass bearing is. It's going to tell us a value between 0 and +360. We're going to take the toggle button we placed moments ago to the PID active. So when we want to turn on the system, we hit that. Now, I actually did forget we are going to need another keypad on this system because this system, wait, make sure, yeah, it goes down there. We're going to need this, say input compass heading, and this is going to get hooked up to electricity. So you will be inserting a value between 0 and 360 into that keypad, and that is what the PID is going to try and hold to for your compass heading hold. This will be for the set point. So we have all of these, and so believe it or not, this compass heading hold system, for the most part, that's set up. We're going to test this momentarily, but we're just going to adjust the PID to 0.00. We'll start with a 5. Integral will go 0. Dampening will go 3. We really don't want this to overshoot, and so we'll do 3. If things become problematic, we can adjust that. We will adjust that. I'm going to spawn it. Speed, we'll just get a set speed here. We'll go ahead, turn on the plane. So we can check that our compass bearing works. If we turn to the right, we're going to keep turning to the right just to double check everything. 300, that looks normal. 350, 360, yep. And so now once we surpass 360, we goes to 0. And so here now we're at, say, northeast, and now we're at east. East is about 90, or exactly 90, so right there. So yeah, so that value is working. We're going to go ahead, let's center up the plane, stabilize bank angle, and we'll go ahead and we'll say we want the plane to hold at 400 for now. So let's get everything, let's pull this up a little bit. Let's get to 400. There we go. Now what we want is we're going to test our bearing hold, so let's get a value, we'll say 200, well, excuse me. We'll say 200. We'll say a value we want 200, and that's going to be for our compass heading. And as you can see, the compass is moving. It's going to try and get to 200, which would be, I think, southwest. Yeah, so it's going to be close to south and a little bit west. So we don't want it. So the PID, as you can see, is kind of freaking out here on the rudder. Hopefully this is not going to have any drastic consequences. Working nice and slow. We don't want it to be, it doesn't have to be lightning fast. We do want the compass heading to be more sensitive, because if you say put 359 in, if it overshoots, it is going to go all the way around long ways from 0 to 1 to 2 to 3, all the way 360 degrees. And so we do want a system where it does not overshoot at all. The alternative is you would have to use what's called a delta into a microcontroller per se, and you have to do some very complicated mathematical stuff that is extraordinarily in-depth, and this tutorial will not be covering it. So for your compass heading hold on this tutorial, you're just going to have to tune the PID to be very gentle, as it does not overshoot at all. As you can see, we put in 200 and we have not yet reached it, but we are getting very close to it. And so we're just going to wait. Now, because this is hooked up to an ad block, I can input my own rudder controls. So I'm going to hit the right arrow to input my own rudder controls, and we can kind of assist it in getting closer to 200. As you can see, our PID is very flipping out, so I believe this will mean I might need to make these terms a little bit smaller. And as you can see, my PID is very much freaking out. I do not like this. I do not like this, so we're going to go back and we're going to adjust the PID to cater to my needs. Money tutorials do not include this part where you tune the PID and you actually finalize everything. This one will. I'm pretty sure this side was my to make sure you're working on the right side, we're doing compass bearing, we're doing compass hold, and so just make sure it comes to the right area. Yep, this is the side we're working with. So I noticed it was too sensitive, or it was working too much, and so we'll make that smaller. We'll make that a 0.002, and we will make our derivative gain 1. We will put that at a value of 1. We are going to save this and test it. Turn our aircraft on. Speed input, we'll do 80. Activate it. Center hold. 400. And then let's say we want to go exactly east, so we'll input a compass heading of 90 to represent east perfectly, and we will activate our system. And you can now see our rudder appears to be a little bit more stable. Let's just give this a minute and see what it does. We can close our door for the first time since this tutorial. 155, 150, so our PID is working. So now as we get closer and closer to 90, ideally it's going to deaccelerate. And we just make sure, we need to make sure that we don't overshoot too much past 90. Again, I can wiggle the rudder manually a little bit to the left and to the right if I want. I can manually put in these inputs since it's hooked up to an ad block. I'm going to leave it there and let the system correct itself. You can see our altitude hold system from earlier is working just fine. We put in 400 and it's holding at a value of 401. Our speed hold works almost perfectly. We have put 80 and it's holding at pretty much right there at 80. Let's take a look at our compass. Still just very slowly trickling. So the positive to this, that it's taking this long, is it means it is most likely not going to overshoot at all. Or if it does, it'll only overshoot. It won't overshoot by a full value. So that way, if you plug in 359 into your compass heading hold, it will get to 359 and it will not ever exceed a value of 360, or rather 0, and then it'll do the full loop to go around. It'll go from 0 all the way to positive 1 to 2 to 3, all the way 360. You do not ever want that to happen. And so you just need to make it so you tune your PID to be very sensitive and very gentle. Currently, this system is still in a questionable state since we have not reached 90 yet, and I input 90. We are getting there. It does appear that it will work, but I just need to make sure that it works to what I need it to do. So we'll continue to wait. So I suppose I could make the proportional value slightly larger. But we will see what happens here. And remember, you only have to get it working within, I would say, about half of a degree. If you get it working within half a degree, that'll be perfectly accurate enough, because if you think about 360 degrees, that's already quite accurate. So let's say you need to go exactly 304 degrees. Well, if you're going 304 and a half, you're still going to, for the most part, get exactly where you need to be on the map. You would never really need to be like exactly perfect. That would be quite rare. Even if you're traversing the entire length of the map, the difference of half of a degree is most likely not going to be a detrimental change. Currently, I do not actually like this. I think the proportional value needs to be slightly larger. This is just working too slow, so I might make the proportional value, I might double it. I think it's at 0.003, we might make that 0.006, or maybe maybe even, I don't know, we'll have to take a look at it. For now, I'm going to use my rudder inputs to try and get it closer to 90 and see what happens. So you saw it, I used my rudder input to get it closer to 90, and it's going up. I don't know why. That's not what I want. I'm going to put it to 87 and see what happens. So at least it does go up normally. So it looks like it's working faster. Perhaps my propeller, perhaps because of the direction my propeller is going, it's more difficult for the plane to turn one direction as opposed to the other. But as you can see, even this is pretty slow. We are getting closer to 90, it looks like, so that's good. And so we'll just auto-correct it. We'll just try and get it at 90 exactly using the rudder. And we'll see what the PID does a little bit to the right. We'll see what the PID does here. So it looks like my proportional value just needs to be stronger, so we'll take care of that now. What I had there wasn't a complete failure. It still worked for the most part. It was just slightly inaccurate. So we will come to the PID. We are working on this side. So we had a value of 0.002. I'm actually going to make it a value of 0.005. So that's going to be a little bit more than twice as powerful. Just a little bit more than twice as powerful. Hopefully it is enough of a difference to where we can speed things up a little bit. Activate our speed hold. We'll put in 500 now. We won't activate it yet. We'll activate our center hold. Turn the engine on. We will activate our toggle hold. For our compass, we'll do it again. We'll go for, we'll go for a value of 170. So like pretty much mostly south. So let's say we want to go mostly south. We're going to go ahead and activate that. We want an altitude of 500 as well, and so the altitude is going to work there with the PID. We have all of our systems. All of our systems are active. So you can even see our gyro is quite centered. Here is our compass bearing. This is what we're working with now. We just need to make sure this does not overshoot at all past 170. I have noticed that getting the compass bearing hold system to work is the most difficult of all of the systems. And I would say the altitude hold system is perhaps the second easiest to get working. And I think the easiest system to get working is the speed hold system. For whatever reason, the engine throttle is kind of like a very versatile thing. So your PID tuning for getting a speed hold system for the engine's throttle, it always seems to work pretty well. It does not require any fine-tune adjusting, really, hardly ever. However, the compass bearing hold system, it usually requires a lot of attention. So as you can see, this is quite ideal so far. We are very slowly getting towards 170. You can see our decimals just barely moving lower and lower to get to 170. This system, I'm going to wait for it to really get all the way there and stop moving, but it doesn't appear like I'm going to be getting any detrimental overshooting, which is exactly what we want. We never want an overshoot of at least more than half a degree. Sometimes it's okay if it's like 0.60 degree or 0.50, but you would never want like a full degree overshoot. We'll wait until this pretty much remains static. Another thing I forgot to add that we will do after this is we will put in our fuel system. We'll have a fuel display gauge that we can hook up, and I'll show you how to hook it up to where you get a fuel percent reading. So this is actually pretty brilliant. It looks like it's going to be within a quarter. It looks like it's going to stay static within a quarter degree, so a little about 0.25. That is going to be quite accurate. My previous system was about only half a degree within its range. So this is actually better than what I was expecting. We're just going to give it another, we'll wait a little bit longer, see if it does anything with 0.23, see if that goes down or up anymore at all. But it looks like that'll be static. And again, because of the way we hooked up our bank angle system, we can turn to the right a little bit, and then it'll automatically center. Oh. Because we adjusted the bank angle, you can see it tuned, our compass bearing was messed up a little bit. But that works with how I want it to work. So we're going to sit down again. And now we're going to do a pretty big test. We're going to go to 359. If this system overshoots, it'll basically be broken. If this system overshoots at 359, it's going to continuously do the full circle all the way around. So we just really want to make sure this does not go a full degree over 359. So this would be if you want to go exactly north pretty much. I suppose you could do 0. But if you want to go pretty much exactly north, you would input 359. Here's our compass bearing. It's still working. As you can see, we're at 349, so we're only 10 values away. And you can see already it's starting to slow down exponentially. It's going to continuously slow down. You can even watch the line start to break. Slow. No, the line looks like it's moving at a consistent speed, I guess. But the numbers are very gradually getting closer to 359. So we're going to be at 357. If you watch closely at the decimal places, you can just see it very slowly start to deaccelerate more and more. Its ticking should continuously decrease until we reach 359. Suppose we can put up our landing gear. I'm not sure if that'll change much of the plane's configuration. You can see, so far from what you can see, this plane is in no danger of overshooting 359 because of how slow and because of how gentle our system works. We are in no danger of overshooting 359. In fact, to get to 359, it will take its time. We're only about to reach 358, so within 1 degree still. We'll wait for it to get to 350. We'll wait for it to get to 358. If we want, we can adjust the rudder manually, very gently. I'm going to tap the right. Just going to tap it. I just tapped to the right a little bit. Tap the right a little bit. Interestingly enough, it starts to decline. It's not quite comfortable when we're at 350 here. It's not quite comfortable getting all the way to 359. Let me make sure, 359, yeah. Interesting. If you were to overshoot, it would be quite bad. But we are within 1 full degree of it. And so I guess if I wanted to, I could hit 360 and we could watch this, try to get to 360. So now now if you want to go exactly 359, you can just say 360. So this system is satisfactory enough for me, I would say. It's not in any danger of overshooting, and for the most part it holds where we need it to hold for a basic level of compass heading hold. So we are going to turn all this off, and we're going to go back to the base. In this final part of the tutorial, I am going to be showing you how to do a fuel reading in percentage, and I will also be tuning the aircraft propeller and adjusting how many blades it is to get the optimal speed. So let's begin by getting a new dial, and this is going to display our fuel. And I'm also going, oh shoot, I can't do it there. We're going to do 2 dials to display our battery and our fuel. To make it prettier, why don't we actually just do a gauge, give it a different amount of variation, kind of have multiple instruments. The gauge will display 2 values. So we have on the gauge, we have a secondary display value and we have a primary display, so we can actually display 2 different values. And so for the secondary one, it's going to display it in red. I'm just going to take the battery charge, and so we hook that up to battery, and so we can just do display name fuel, and we'll get the fuel part from our fuel tank in percent in just a moment here, but bear with me, fuel percent, and then we're going to go battery, and then we're going to type in red. So because the secondary value is displayed in red, and so just to keep things simple, we put that here, save it. Now let's get on to the more tricky part. I'm going to grab a quick microcontroller, but you don't need to worry about that yet. You will only need a function block, and so I'm going to place both of them down. So all you need is a function block. So this is your function block. You only need to put this down. You only need to put the function block. But now, really quick, let me go into here so I can get the value. So when you're using a large fuel tank, that's right, you are using the value 678.5. This is roughly the value you would use. This is roughly the amount of liters that's stored in the large diesel fuel tank or any large fluid tank in the game. I believe the medium one is around 200-ish, maybe a little lower than 200. You will have to check, but you do X divided by 678 times 100. So we're going to come out to our function block and do that. X divided by 678 times 100. X divided by, okay. So come out here, and we're going to do, in parentheses, X divided by 678.5, and then there. And I believe we do a percent. It looks like percent out of 100. No, I don't think that's right. Hang on. Let me come in here. Let me just double check what the other part. No, times 100. Excuse me. My apologies. It's times 100, not percent 100. Times 100. So in your function block, this is all you need to do. You need to do that for your large diesel tank. If it's a large tank, that's what you put in. Times 100. So there's our function block. And now what you're going to do is you're going to take your fuel tank, and it's called tank content. So you're going to take tank content, and you're going to put it into the function block, and the function block will have that. And so again, if you're using a medium diesel tank, it'll be a slightly different value. And now what I'm going to do is I'm going to display this over here to our primary display value. And we are going to save this and see what this looks like. So we're going to come in here. And so you can see in red it says 1. In black it says about 98. So the red is our battery charge. There's our fuel percent. It's not going to be perfect ever. It's about within 2, but what we can do is we're going to take, let's say we take another dial. And because sometimes the tank levels change a little bit depending on how many are next to each other. So let's hook that up to electricity. And we're going to get an exact reading of what this tank content is reading here. Value to display there. So we'll just call this fuel. This is how many liters. It displays how many liters. So we're going to put liters there. We're going to save. And so we're going to get the exact value because we put 678, but sometimes the game's a little buggy. Sometimes it changes a little bit. So it's actually reading 664 for this. I think when you have two fuel tanks together, they kind of blend. So that's 664. And so we'll come and we'll make it lower. We'll make it, we'll call it 670, we'll say. Now it doesn't have to be, we don't want it to be exact because sometimes it'll do wonky stuff with the percentage. Sometimes it'll display either too much or too little, depending on how, when you like get lower. And so here we're at 99. So this is much closer. So fuel, there we see our liters. Here's our percent. So that's a lot closer. So we're at 99 out of 100. And so pretty much you would say, okay, yeah, we're pretty much at 100% fuel. Now there is another way, well, not another way, but the way you also continuously check this is you're going to take your select tool, select the fuel tank, and adjust the actual fill level. And so let's say 75%. So now we know it's the fuel tank is actually at 75%. And now we're going to come here and we're going to see, oh, it reads 78. So that's not quite as good. But what happens when we get to, say, 50? Put it at 50. We're at 49, but we'll spawn it anyway. So we're at right around 50. Let's see what our percentage is reading. 52, there we go. So that's why, so before it was like way off, but you can kind of get a general reading. So now let's come down to, we'll come down to 30, we'll say. We'll come down to 30 on the fuel tank and see. And now as long as this gauge displays something around, there we go, 32.5. Close enough. As long as you're within about 2 or 3%, that's going to be close enough. It is quite difficult to get it exact. Let's go ahead, bring this all the way down. Let's say you're down to 10% fuel. Spawn it in. And when you're at 10% fuel, let's see what this would read. 11.82. So yeah, so now we're within even closer than 2%. So this will give you a perfect, semi-accurate to like what you would need it to do. This will give you a functioning reading of your percent fuel roughly. Exactly. This will function exactly how you would need it to function, basically. So we put our fuel at 100%. So we're going to save it. And we'll give this one last test run. So we have our door. We can close it. Oh, another thing we forgot to do before we do anything, I almost forgot. We have to do the steering for the taxi. And so we're going to take our rudder controls for left and right, the seat data. There's throttle. I'm trying to find. Here's up and down. And then here's left and right. So where it says left and right, you're going to take that over here to steering. steering on those wheels. And then also we'll say for the brake, we'll also probably want to get the brake working. So we'll just put that up to say 3. That'll control the wheel brake in the back. We're going to save it and spawn it. And we're going to see what the steering does. So this is for when we taxi. So we're out of the plane, third person. See that, how the both wheels are moving together? So one of these needs a numerical inverter. So let's see, I'm going to hold to the left, hold to the right. Okay, so the wheel on the left side needs a numerical inverter. So we're going to come out here. Need a numerical inverter. Numerical inverter. And we'll just place this down right up here. Why not? And so for our seat data left and right, this one of them is actually going to come into this numerical inverter, number to invert, and that's going to go to the wheel on the left. Save it. And now, if I get stopped from clipping into the ground, we can come into the plane, start up our engine. Now, instead of doing all of our fancy inputs now, we're going to practice taxiing. And so if I want, we can go left and right on the wheels. Perfect. And so I'm just going to very gently adjust my prop pitch. So we can go out to here. It's very controllable. Speed 6, nice, very controllable. If I need to, I can hit 3 to brake, so we're at 6, 7. I'm going to hit wheel brake, and look, there's the wheel brake. It slows us down nice and good. Release the wheel brake. We can taxi, and now, if we need to go in reverse, let's say we overshot, we need to go in reverse, we go negative, we do a negative input on the prop pitch, and as you can see, whoop, I didn't mean to hit that, yeah. But as you can see, we are going backwards. So we'll hit, let's say, oh, we need to hit the brakes. We hit the brakes, nice. Now we can angle our prop pitch forwards. And then we'll release the wheel brake. So our prop pitch is going forwards. Ignore that. I'm going to manually increase my engine throttle. Perfect. Now we can put in our speed input. Why don't we go to something like 50? We'll activate that on. As you can see, our speed hold is trying to get us to 50. We'll go like 60, a little bit faster. And then we're going to hold our altitude. Why don't we come down to, we'll say 13 here. Activate our, oh, not yet. We still have some land. We'll activate our bank angle hold now though. And so now as you can see, and also we'll put up our landing gear. There we go. Landing gear is up. And then now we'll activate our altitude hold. Our desired set point is 13. We're at 24. You can see our plane is going to very softly and very gently descend here. You can see our fuel reading. We're at 98%. Battery is 0.85, and so we might need another battery, but you can always put in another battery in your plane if you need it. We won't need to cover that in the tutorial. Altitude is going to hold here roughly. Desired set point's 13. Looks like we're at 14. This is very close enough. And you can see we're going to roll the plane to the right, and I'm just going to let go of the controls. I have let go, and I'm just going to let our bank angle center hold system take over. As you can see, it snaps into place. And it will hold here, nice and center. We can even come down here, look at our gyro, perfectly stable. And look at our altitude, 13.99, 14, It holds it within one value. It holds it close enough. Speed is 59.9. Speed's trying to go 60. So yeah, that's close enough. Close enough. We didn't do our compass bearing. But as you can see, this plane works perfectly to what we would want it to do. It works within our standards. And I hope you enjoyed this tutorial. We have gotten everything working and functioning properly in this plane. This is a perfect intermediate advanced plane that it should accomplish all of the things you need it to accomplish. We're able to taxi, toggable landing gear. I hope this guide helped you accomplish all of the things you wanted to accomplish, and I hope the simplicity and the repetition of using these PIDs has helped you become a better builder. As you noticed, this build did not require any microcontrollers, as those are very complicated, but as you can see, you can still do very advanced stuff, such as a bank angle hold system in your aircraft without the use of microcontrollers. A quick little footnote to this video, I did change the propeller from 4 propeller blades to 2 propeller blades, and I switched around to like 3 and 6 to kind of test which was fastest. It turns out 2 propeller blades was the fastest, which would yield a top speed of 120, as you can see here. The speed hold, I'm putting in 160 to try and go as fast as possible, but it looks like the top speed maxes out right around flat and even 120. Keep in mind, as you go faster though, you're going to deplete your fuel much quicker. As you can see, our fuel percentage is depleting much faster at these higher speeds, and so keep that in mind. Additionally, if you're going to be doing extreme flight maneuvers such as this, such as barrel rolls, I recommend you keep your center hold system turned off, but when you go return to normal level flight, if you want to turn to normal flight, you can just turn on your center hold system, and you can still make fine adjustments such as this. But again, for extreme flight maneuvers such as barrel rolls and loop-de-loops, I recommend turning off your center hold system for optimal performance. Hope this video helped you out a lot. Thanks for watching.